In the video for number 11, we already came up with the sign chart, so I'm just reproducing it here. So if you haven't seen the video for number 11, check that out. And then I just kind of did another sketch of that same sign chart up here. So we have boundary values of -1 from setting x plus 1 equal to 0, and boundary value of 5 from setting 5 minus x equal to 0. We plugged in test points and got a negative, positive, negative pattern for our sign chart. And that was for number 11, where we had 5 minus x over x plus 1 less than or equal to 0. So now for number 12, we have 5 minus x over x plus 1 is strictly less than 0. So because we have strictly less than 0, we're looking for negative values. And less than 0, we're going to be using rounded parentheses. And remember, because we're dealing with a rational expression on the left-hand side, we have that extra restriction, which says that our denominator can't equal 0, which means that x can't equal -1. So that means I can never have a square bracket next to -1 when I'm writing out my solutions here. All right, so if I'm looking for the negative intervals, I'm going to go from -infinity up to -1. And then I'll go from +5 up to +infinity. Connect this with a union symbol, and I'm using those those rounded parentheses because it's strictly less than 0. Now for number 13, I have greater than or equal to 0. So that means I want positive values. Because it's greater than or equal to 0, I'm going to be using square brackets. The only exception is, remember, I can't do that for -1. So if I have -1 next to a square bracket, I have to erase that and replace it with a rounded parenthesis because x can't equal -1 no matter what. Okay, so if I'm looking for the positive interval, that goes from -1 up to +5. That's my positive interval. Now at -1, normally I would put a square bracket, except x can't equal -1, so I know I have to put a rounded parenthesis there. But for +5, I can go ahead and put the square bracket. All right, so that brings me to number 14. Now I've got a rational inequality, x plus 5 times x minus 3 over x plus 1, the whole thing greater than or equal to 0. So it's already factored. Setting x plus 5 equal to 0 gives me x equals -5. If I set x minus 3 equal to 0, that gives me x equals 3. And setting x plus 1 equal to 0 gives me x equals -1. So these will be my boundary values on my sign chart down here. So -1, I'll draw my divider. At -5, I'll draw my divider. And then at +3, I have another divider. Okay, so I'm going to pick out my test points in each of these intervals. So maybe I'll pick -8 on the far left, and I'm going to plug it into each of these factors. So -8 plus 5 times -8 minus 3 over -8 plus 1. -8 plus 5 would be negative. -8 minus 3 would be negative. And -8 plus 1 would be negative. 3 negatives give me a negative result overall. In the middle here, or sorry, on the left, I guess, let's use maybe -3 as a test point. So -3 plus 5 times -3 minus 3 over -3 plus 1. So this is positive times negative times negative. Positive times negative divided by a negative gives me overall a positive. 2 negatives make a positive. I'll pick 0 next because 0 is my MVP. It's usually the easiest one to plug in. So 0 plus 5 times 0 minus 3 over 0 plus 1 gives me a positive times a negative over a positive. So positive times negative divided by a positive gives me negative overall result. And then finally, maybe I'll pick 10. Doesn't matter what I pick, as long as it's in the interval. 10 plus 5 is 10 minus 3 over 10 plus 1. So that's positive, 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 which is overall a positive. So I have negative, positive, negative, positive. So if I'm solving x plus 5 times x minus 3 over x plus 1 is greater than or equal to 0, I'm looking for a positive interval. I'm looking for my positive intervals. I'm going to use square brackets, except remember that x cannot equal negative 1 from that denominator factor. So that's my only additional restriction. Okay, so looking for my positive intervals. My positive intervals are here from negative 5 to positive 1, and then from positive 3 out to infinity. So using my square bracket, negative 5 to negative 1. Now here, remember that I can't use a square bracket at negative 1, so I'm going to use my rounded parenthesis, then my union symbol, then square bracket for 3 out to positive infinity.